and it's due a week from Thursday. So we'll be back on the usual schedule. Yeah?
Is there a preference for pen or pencil when we're ready?
You say that again?
Is there a preference for pen or pencil when we're ready?
A preference for pen or pencil? Either one is okay, but what really annoys us is when you use a red pen. So don't use a red pen. That's what we use to grade with. Yeah?
So there's nothing to do this Thursday?
There's no assignment due this Thursday. But the assignment is out, so you can work on it if you wish. Okay? Yes. Yeah. So the labs tomorrow go over the sample midterm. The optional review sessions will go over the problem sets. Yeah?
When we write the methods on the exam,
It covers through the first 6 weeks of the class, which does not include the week right before fall break. So that includes the first 6 weeks of class and the first 6 assignments. So PS6, which is the pie chart bar graph thing, that's included, but nothing after that. Okay. Any other questions? Yeah?
do we have to try and catch exceptions when we write methods on the midterm?
Yes, you have to use try-catch on the midterm. Well, yeah, if it's appropriate.
Okay. And do we have to know what specific themes throw specific exceptions so we can catch those specific exceptions, or just like general catching?
Well, so he's trying to get specific about, do you have to memorize what methods throw what exceptions? No, not really.
Okay.
But you need to know how and why you catch exception and throw them. We understand that you don't have eclipse on the exam, and so we don't grade it as strictly as eclipse would. So we give you a little bit of slack in the syntax. Okay? Okay, so what I've got on these slides, I just made lists of things that we've covered in the first 6 weeks of the semester. But the exam is not about memorizing this list or anything like that. If you have trouble remembering things, write them on your cheat sheet. The idea is that you should be familiar enough with what's on these slides here that you can use them in writing programs. Now, I could fly through these slides and do it fast enough that no one asks a question, and that wouldn't be much of a review. So what I'm counting on to turn this into a review is for you to ask questions as I go through the slides. So they're sort of meant to spur questions. But if there are no questions, we'll be done pretty fast.
Just one more question.
Yep.
Will this video be posted before the test Wednesday?
Yeah, this video is being live streamed, and so it's available right after. It's available right now, actually. But lately, we're on a winning streak lately. The problem is I got a new laptop now, and I'm worried that it may fail or something. So I think we got it going. All right, so this is on the slides in case you forget. How many of you think you might go to Jack's review session today? Okay, I think the room's good. Okay, so we've spent most of our time so far this semester until before fall break, certainly in the first 6 weeks, learning about how to create programs that use static methods. And that's one way you write programs, is you write static methods. That's one building block you build. The other building block are classes, and that's what we're talking about next. So these are some high-level concepts that I've talked about from time to time, and that we've employed always. And the first one is abstraction. So abstraction is really key to programming. It's a habit of mind. It's a mental habit where you take a simpler view of a complex entity by selectively ignoring details. Okay? What does that have to do with static methods? Where do you go? Yeah?
Potentially breaking a more complex method down into smaller helper methods.
Okay, so he said breaking a more complex method into smaller helper methods, but that's actually decomposition, which is the next point up there. What's abstraction? Yeah.
Not worrying about what static means.
Okay. He said, not worrying about what static means. You know, everyone worries about it, but if I say it really doesn't matter for now, don't worry about it. It's a detail you can ignore. Yeah?
The only thing you have to care about is what to do, not just how to do it.
Okay, so if you're using a static method, you don't care how it's implemented. You don't have to look at the code. So when you use a static method from the Java library, you know, you're not going and looking at the code to see what it does. You're looking at the java.com comment to see how it works, what it does for you. That's abstraction in action. You're ignoring all the details about what's inside the method. And you're just viewing the method in a simpler fashion. You're viewing it in terms of what's its name, what parameters does it take, what does it return, and how do they all relate. That's taking an abstract view of a static method. Programming would be a lot harder if you didn't do that. I mean, imagine if you could not sensibly make use of a scanner, for example, unless you went and examined the source code for the scanner and understood every nuance of its implementation. You wouldn't get very far, very fast. It's a very complicated thing, but if you just view it abstractly in terms of what services it provides to you, then you can make huge progress. So abstraction is very important. Decomposition, as he just said, he gave us an example, which is taking say you've got a method to write, and it's fairly complicated, but you realize that if you just had a couple helper methods, it would be simple to implement the main method, the actual method you care about. That's decomposition, breaking down something that's complicated into smaller pieces. And you've begun to see how that works. The problem with decomposition is we start out doing fairly simple methods, and so there's not a whole lot of decomposing to do. But as we go along, and especially as we get into more seriously into object-oriented programming with classes and inheritance and such, it'll start to make more sense. It'll be a lot more obvious to you. Have you used algorithms yet? An algorithm being a step-by-step description of how to carry out some task. Have you made use of algorithms?
Yeah.
Yeah.
We have.
Sure. Every time you implement a method, you are basically designing a way to do what you need to do. That's an algorithm. So you're inventing lots of simple algorithms. And that's a really rich area of study. If you go on to 2420, that's a major point in 2420, is studying sort of classic algorithms for solving common problems like sorting and searching. And finally, we have this idea of a method, and we're sort of circling back to abstraction. So a method is an abstraction of an algorithm. So the abstraction being we ignore the details of the algorithm and just look at the parameters in the Java doc. Okay? So those are some high-level concepts. Any questions I could answer about this, or any thing anyone would like to add? Yeah?
When you say behavioral specification, are you referring to what's being returned?
Well, when I say behavioral specification, I essentially mean the Java doc. And the Java doc will describe what's going to be returned in terms of the parameters. So it relates the parameters coming in and the result going out. Okay, so when we write a program, what we do is if it's at least the programs you've written so far, is you figure out what program you're going to write, you decompose a program into methods. Now you got to implement those helper methods. And then with the helper methods, we create a stub for each method. A stub being basically a method with no body, or at least maybe a return statement so the thing will compile. Before we implement the method, it's good to create unit tests for it. Now earlier in the semester, I gave you unit tests for all the methods you were going to write. As time has gone on, I put more and more of the responsibility on you for making unit tests. And I know just from experience, maybe all of you are different, but students I've had in the past, even if I asked them to create unit tests before they write the code for the method, they don't really take that to heart. They tend to write the method and then write the unit tests. But if you can get over that, why is it a good idea to have unit tests in hand before you try to implement a method. Yes?
If you've got a test for something, you can see how it's supposed to behave versus how your program actually behaves, and it makes it easier to debug.
Okay, so he said if you have if you write tests for something, then you sort of have an independent accounting for what the method is supposed to do. It's independent of how your method is actually implemented. Okay, what's another reason? Yeah?
When you've gone through the trouble of thinking about everything that could go wrong that you need to test for, you'll have that in the back of your head when you are going to actually write the method, so there'll be less backtracking to fix it.
Okay. So that's an important point that he just made, which is the experience of writing the unit tests forces you to think about all the aspects of how the method behaves. And that helps you when you go to implement it. Right? Think of another method, another reason why having unit tests before you start coding is good. Yeah?
So if you've gone through and made your tests, that means that you've taken the extra time to fully understand what your method is supposed to do.
Okay. So that's similar to the first point, which is you're taking the time to understand what the method is supposed to do. Did you have a different one?
Oh, yeah. Sorry, I'm sick. When we do the unit test cases first, we can set out like the edge cases and make sure that our program works with those edge cases, which is a problem that we have.
So she's talking about setting out the edge cases, sort of the weird cases that when exceptions are thrown and such. But the one that I guess what no one is mentioning, and which is actually a real good reason for having unit tests before you start coding, is you'll have unit tests before you start coding. You'll be able to test your method as you implement, instead of finishing your method and then having to write some unit tests. It's nice to have, you could start with your method and just write something that throws an exception that's supposed to be thrown. And then you can test and see if that exception is thrown properly. Think of the difference it is when I give you the unit test to start with and you code versus when I don't. Most students feel a lot more comfortable when they've got some unit tests to back them up. And you can have that all the time if you write the test first. So the idea is we specify the stub, we write the unit test, then we implement the method and test it. And then we use these to implement the original program. That's sort of the design process so far. And we keep talking about specifying or behavioral specifications. I'm talking about what goes into the Java doc, which is to describe very precisely, but in English as opposed to in code, the behavior of the method in terms of its parameters. So under what circumstances does it throw exceptions? What exception does it throw in those circumstances? What does it return when it doesn't throw an exception? Does it do anything else besides return something, like bring up a console window, a dialog window or something? So that becomes your Java doc. All right, we've it's good to be familiar with some general programming language concepts. So a programming language such as Java, and there are many more, is just a formal notation for describing computations. And a program is a description of a computation written in some programming language. The thing to remember about good programming is you are describing the computation to two different audiences. You're describing the computation to the computer. You're also describing the computation to a human that might read it later, including yourself. I don't know if you've had this experience yet, but I've had it many times where I write some code and I come back later to it, sometimes just the next day, and I don't understand it. Why did I do this? I don't remember. And hopefully it gradually comes back to me. So even if you don't have a TA grading your program, if you write it in a sloppy fashion or don't include comments, you're going to regret it if you have to live with that program. A compiler is a translator. It translates from one language to another. So in Java, the Java compiler, which is built into Eclipse, goes from Java to Java bytecode. The C compiler would go from C to machine code. And it used to be, students are having trouble with the concept of compiler because they had to run it manually every time they wanted to do the translation. They were very aware when they were running the compiler. It's just sort of happening in the background. You're aware it's run only because it underlines things in red to tell you that there's some problems. Any program ultimately has to be interpreted. The instructions in the program have to be carried out on the computer. And there's two models, the Java model, and sort of, there are lots of other languages, where this is the norm, is that there is a program, a separate program installed on the computer that interprets the Java bytecode. So if you have that program, which is called the Java virtual machine, then you can run Java on your computer. The other model, which is what's used by C and many older languages, is that the C is compiled to machine code and the code runs directly on the hardware. So what that means is, if you compile a C program for one kind of computer, you have to recompile it for a different kind of computer. And so there's different compiled versions of it, depending on what computer it's running on. Whereas with Java, you just got to make sure there's a JVM. So the program's a little portable. But the other thing is, with C, something like C, you don't have the overhead of the JVM running. And so C programs can be made more efficient for that reason. Yeah?
So a compiler translates what the user types into something that the computer can understand.
Okay, so he said that compiler translates from what the user types in, source code, like Java or C, to a lower level language the computer can deal with. And yeah, that's pretty much it. Okay. Any other questions? We didn't make a big deal about this, but it's, I like to mention it because it's important to be able to put what you're learning in context. All right, now we're going to go through a series of slides that just talks about how Java programs are made up. And if you have questions about specific aspects of Java, be sure to raise your hand. It's a good place to ask them. So at the top level, a program is made up of one or more classes where the classes are organized into packages in some way. And these classes can provide static methods. So as far as we're concerned, a Java program is a bunch of classes, often just one class, and the class provides static methods. That's our picture from the first 6 weeks. Okay? So a static method provides a new abstract operation, if you will. And to create a method, you have to give it a name. You have to say what its parameters are. You have to say what value it returns, if any, what kind of value it returns. Sometimes you have to declare whether it may throw an exception. Depends on the exception. And then it contains, the body is a sequence of statements. So that's what you've been doing the first 6 weeks of the semester, is implementing static methods according to that recipe. Are you comfortable with that notion? Yeah.
As far as declaring throw an exception, what do you mean by specific ones?
Okay, so sometimes at the end of your method, in your header, so you have some, let's say, void f, take some parameters, and then you say throws IO exception, and then there's a body. What does that throws mean? What does it mean when it says throws IO exception? Yeah.
It means that the method might throw the IO exception and not handle it. So when this method is called by something else, it'll just give that exception to the method that calls it.
Okay. So I'll summarize what he just said. Throws IO exception does not mean an IO exception will be thrown. It means that under certain circumstances that are out of the control of this method, an IO exception may be thrown. And that anyone that calls this method has to be aware of that. That's why it's put there, so you're aware of this may happen. And the calling method has to deal with it, either by catching it or by advertising that it throws it as well. Yeah?
So by itself, it doesn't really do anything unless you have something in the code.
specifically throws.
Well, right. The compiler will complain. If you leave this off, and you're calling some method in here that can throw an IO exception, the compiler will complain. If you put this on, well, now I'm not sure. I was going to say if you put it on in your code, and there is no code that could throw that exception, I'm not sure the compiler does complain in that case. So I'll leave that aside. Yep.
If you resolve that exception within the method, do you still have to do that? Or is that only if it can potentially be put on to another, or like put off for a later method?
Yeah, so I'll just again summarize what he said. You know, if you're calling a method in here that could throw an IO exception and you've got a try catch to catch it, then you don't put that there. It's only if that exception can escape the method that you have to advertise. Now, some kinds of exceptions you have to advertise here, some you don't. What are the ones that you do? What is it about this exception right here? What characteristic does it have? That an answer or is it a stretch?
I forgot which way it goes, but it's either checked or unchecked exception, and if it's the checked, like, you can't continue running.
Okay, so this is a checked exception. Essentially, there's no way to look at the name and know it's a checked exception. But checked exceptions tend to be exceptions that you, the programmer, really have no control over. So in this case, you write a method that opens a file and reads it into a scanner. Maybe that file, after you open it, it disappears. Someone deletes it. Or maybe it wasn't there in the first place. You've got no control over files outside your program. So you've got no way to code so as to prevent the exception from happening. It can happen unexpectedly when your program runs. And so Java requires you to advertise it. Other things like array index out of bounds exception, you can write your program, if you wish, to avoid that exception ever happening. You just got to avoid using bad indexes. So things that you can avoid, reasonably avoid, by being a careful programmer are called unchecked exceptions. And typically, if those exceptions occur and aren't handled, that's a program bug. That's a bug in the program. Whereas these exceptions that sort of depend on outside influences are checked exceptions. And you've got to explicitly either handle them or say that you're not handling them. Yeah?
You think the one who calls this method has to deal with it. So one is catch. What is another solution?
Okay, so to deal with a checked exception, you can either catch it in a try catch, or you can not catch it and put this in the header. This is the other way of dealing with it. Yeah.
So when you say that there's an outside information, that also includes like user input?
He's saying, does that include user input? Well, I mean, you know, you can read user input and then try to say the user's supposed to enter an integer and you try to parse it into an int, and it's not an int. That's still, the number format exception is still not a checked exception. Checked exceptions tend to center around things like reading from files. That's really the most common thing that you encounter usually. IO exception. Yeah?
There's a lot of different exceptions. I was wondering, like, on the test, is there going to be a question like, what kind of exception does this throw? And then, like, it's got like a mistake underlined or something like that.
Okay, so he's asking, might I ask a question like, here's a method, what exception might it throw? No, I'm not likely to ask a question like that. Yep.
Do you have example questions?
Say what?
Do you have like example questions?
Yeah, there's a sample midterm posted. Yeah?
Is there any particular significance to the names of exceptions or the exact types outside of reference to the programmer trying to catch them?
Yeah, right. There's no significance to the names of the exceptions. You know, you can name it whatever you want, like any other class. An exception is just a class. But they tend to have big, long names that end with exception, so that they're in your face. You know, there's no mistaking what they are. Yeah?
So if you have an unchecked exception, you don't have to mention throws. You don't need to have a throw
No,
statement.
you don't mention unchecked exceptions up here. Just the checked ones. Yeah?
So could you write that on the main or just on whatever method? Like,
You can put throws on any method that may, in some circumstance, end up throwing a checked exception. Okay, so methods contain statements. And we studied, hopefully, I don't know, that I tried to be complete. I inevitably leave something off. But statements do something to change, they change something about the program. So local variable declarations, int n equals 0, that's a statement. And what it changes about the program is it introduces a new variable. Expressions that have side effects, those can be used as statements. So you would not in your program write 2 + 2 semicolon. Okay? That's an expression. The compiler doesn't like that. Why does the compiler tell you that's a mistake, just to write 2 + 2 semicolon as a statement? Yeah?
Because they're not doing anything with the value.
Right, it figures you made a mistake, because what's the point of adding 2 and 2 and then throwing it away and moving on? It's a pointless statement. So it marks as an error because it figures you can't have meant that. On the other hand, there are exceptions like dialogues.show message dialog. That's an expression, but it has a side effect of putting up a dialog box. And that's okay to use. So there are circumstances where you can put an expression as a statement. There are assignments, where you change the values of variables. There are conditionals, if then else's. There are various kinds of loops we've looked at. Those are statements. There are return and throw, which are ways of ending methods. Try-catch blocks for dealing with exceptions. And we briefly talked about break and continue, statements that go inside loops as well. So these are all statements you need to be familiar with. Yeah?
So a statement is normally just a line.
Well, I hate to say a line of code because sometimes it's too big to fit on a line. And some statements are compound. Like a while statement, consists of while something, and then a bunch of statements. So that's more than a line of code. Yeah?
The local variable declaration would be like int x equals 0.
Right. Int x equals 0, double d equals 3.14. That's a local variable declaration. Yeah?
Can you remind me how break and continue work?
Okay.
Well, I know break, but continue.
Okay, so if you have a loop, and I'll use a while loop, but any loop will work. If somewhere in the loop you say break, it ends the loop immediately and execution continues following the loop. That's break. Usually, if you have a break, it's going to be inside a conditional. If some condition, then break. And you end up using those when, sometimes loops, they're hard to write. Ideally, you'd write a loop so that it just exits when the condition that's controlling it becomes false. But sometimes it's hard to do that. So sometimes I surrender and put a break in. I try not to use them. And continue just means skip over the rest of the body and then repeat the loop if necessary. So it just says skip the rest of the body, go back to the top of the loop.
So everything under continue in the loop would be skipped?
Yeah, everything under the continue would be skipped.
So would that be like used in like a double nested loop fashion?
Well, continue is used, you can get around using a continue by using an if. But sometimes, you've got a complicated bunch of conditions inside the loop, and you're way down in here, and you realize, okay, in this situation, I just need to skip the rest of the stuff and continue the loop. And the simplest thing is just say continue, skip everything else, start back at the top.
So a break exits the loop.
Break exits the loop.
Skips the rest of the loop.
Continue skips the rest of that iteration, that repetition, that goes back up to the top and repeats it if the condition that controls the loop is still true. Yeah?
And in a for loop, will it result in an iteration? Or will it, when you use continue, will it result in the value increase?
Right, so if it's a for loop and you continue, remember a for loop will have something like I++ up here that says do that every time through the loop. The continue will not skip that. that part of the for loop. That's an advantage of a for loop if you're using the continue. Yeah?
Is there a pass statement of some kind?
A what statement?
A pass.
Pass?
So for instance, if you're in a loop and you want it to continue for a certain scenario and break for another scenario, otherwise just keep going.
Okay, so if you want to, if something break, else continue, else do neither, you just have to put all those things in if else, if then else. If you find yourself, if you put a break or continue in your loop, you've made it hard to understand. And if you're putting both of them in, or multiple breaks, you need to rethink how you're structuring the loop. Use breaks and continues sparingly. They're kind of crude tools. Yeah?
What do you mean by expressions with side effects?
An expression that does something other than produce a result. So 2 plus 2 has no side effect. It's just 4. Whereas the method call that let's say, show input dialog is an expression that returns whatever the user enters, that has a side effect of displaying the dialog box to the user. That's a side effect. Printing something out is a side effect. Yeah?
So I'm just curious, earlier someone about the number of lines in, say, like a for loop or a for each loop. So in just that opening line, how many lines of code are present at that top thing for a for loop or a for each loop?
You're trying to count lines?
How many was lines? Statements.
Well, a while loop is a statement, but it can contain other statements, simpler statements.
Well, I mean, just like the top, like you have, like whether you have wall and then parentheses. I'm saying for like a for loop or for each loop, in those parentheses at the very beginning of the loop, how many lines of code is present?
Yeah, I don't think that's a productive question to talk about how many lines of code it counts as or how many statements. It's just because you've got compound statements that contain simpler statements. It just depends what level of abstraction you want to take. So viewed as a whole, the loop is one statement, but it contains other statements. Yeah?
About the static effect, does that mean something have effect other than in the program, but is that a static effect?
Well, a static method is a method that you just invoke. You invoke it without, you don't invoke it on an object. You just call it directly. There's no implicit parameter to a static method.
Sorry, I mean about the static effect. So does the static effect means the code have no effect with the program, but something else like print out or pop up?
No, so he's trying to get at what static means, right?
No, static effect, sorry.
Side effect.
Side effect. Side effect. Oh, okay. Yeah, a side effect is anything that's observable by the user. So popping up a input box, the user sees that. That's a side effect of the method call. Or you print something out, or you read something in.
I mean something does not affect the program.
Well, side effects affect the program too. It's part of what the program does.
Okay.
Yeah?
You said there's no implicit parameter in static methods?
Correct. No implicit parameter in a static method.
What is this, the implicit parameter?
Well, this is the implicit parameter, but only non-static methods have implicit parameters. So you cannot use this in a static method. Yeah?
I have a question related to the review sessions. Is there a benefit to going to more than one review session? Like, are they different?
Okay, so he's asking, there are 3 review sessions. Are they all different? Well, I mean, I can't say they're going to be identical. And it may be the case that Stefan talks to Jack, and Jack says, I covered these examples, and Stefan's the size to cover others, but not going to happen. It's just, it'd just be whatever, wherever the audience leads them, I think.
What were the times of those review sessions again?
Okay? I think this would be a good time to take a break for a few minutes, and we'll pick up with this. I gotta do this now.
Is there any sample question? How many times did you say that? That was
Okay, so we're just talking about statements. Statements are made up of expressions. And so there are lots of kinds of expressions. There are literals, like 3, a value that stands for itself. There are variables, and variables can either be the parameters to a method, the ones that show up in the header. Those are called formal parameters, or local variables. There should be a line break there. Another kind of expression would be one that uses operators, 2 plus x. Method calls are expressions, as long as the method returns something. The thing that makes an expression is something has a value. A while loop doesn't have a value. A while loop does something. So when you talk about a statement, you ask, what does this statement do? When you talk about an expression, you don't say, what does the expression do? You say, what's the value of the expression? That's the difference. There are new expressions, which is when you create a new object. You say new scanner, or you create a new array. Those are examples of the new expression. And then at the end of the 6 weeks, we talk about array. So array access things, a sub I, that's an expression. So you need to be familiar with that. And I haven't made the exam up yet, but every 1410 I've made up this decade, the first 2 questions have been, here are some expressions, what are their values? And here are some expressions, what are their types? And that's on the sample exam too, and I promise you the first 2 questions on your exam will be the same. So if it's 2 plus 4, what's the value of that expression? 6. And what's the type of that expression?
Integer.
Int. Yeah.
So do you want us on those to say int with a lowercase I? Because on your review, I think it says that it's capitalization counts. So what would
Well, yeah, there's a difference between int with a lowercase I and integer with an uppercase I. And the value of 2 plus 6 is not an integer object.
So it needs to be int.
It needs to be int, yeah. Some people like to write, they sort of print in all uppercase, which maybe you don't want to do, especially when you write the word double. So, yeah, I think that, yep.
Might want to review what's 2 plus 4.0.
Okay, so I might ask, what's 2 plus 4.0? It's 6.0. I'd probably take 6, but it's not an int. The result is a double. In a mixed expression like that, you get a double. Is there another question? Yeah?
I presume you're not going to throw anything like what's 2 plus the letter L?
Well, okay, 2 plus the letter L, lowercase l. What would that be? Yeah? What would it be?
If L is a string, then it would be...
Well, L is a character. L is a character. Sure. So it would be the integer that stands for n, the letter n. No, I won't ask that. Yeah?
Will you give like an expression and then that doesn't have a value? Like it gives a bunch of characters and it says .has next int. Would you expect us to put, like there would be an exception or something?
Well, if I'm asking you what's the value of an expression, you can assume that it has a value, which means it doesn't throw an exception.
Okay.
Right? So I like to ask questions about values and types. Okay. This is, in fact, this whole slide talks about types, variables, and values. So your program computes values. So when you talk about an expression, you talk about what is its value. And there are two kinds of values we talked about, primitives and objects. And we used both from the beginning. We only use 4 different types of primitives: int, double, boolean, and char. You should just know that in your sleep. Those are very basic types of values. And primitives have the distinction that you can write a primitive as a literal. So you can say 24 or the letter X. Those are literals. For the most part, except for strings. Strings are the exception. There's no such thing as a literal object. So if you want a scanner, there's no literal for a scanner. You have to use new. You say new scanner. Objects, to create an object, you have to have a new expression that invokes a constructor. So you see there, new scanner, or new random, or new array list, what have you. And you use an object by invoking methods on it. r.nextInt, s.length, whatever. Okay? And those methods that you're invoking on the objects are examples of non-static methods. Arrays will be covered on the midterm. You can you create it by, there's an example of creating an array of length 10 that contains integers. A new array of 10 ints is a way to look at that. Okay, and as I mentioned on the last slide, to this point in the class, a variable is either going to be a local variable declared inside a method, or it's going to be a formal parameter, a variable that shows up in the header. So those are the variables. But in all cases, a variable has a type that controls what type of value that can be stored. There are thousands and thousands of different classes of objects in the Java library. And you as a programmer, as we're learning now, although this won't go on the exam, can create new types of objects. These are some of the types of objects that we talked about so far in the first 6 weeks of the class. And you need to be familiar with how to use objects of that type. So we've talked about strings. So you should just know the common string methods, like char, at, and length, and substring, things like that, ones that we've used. Good thing to write down in your cheat sheet. Scanners. Know how to use a scanner. I could ask you, write a method that uses a scanner. We've used files. Basically, all we've done with files is pass one to a scanner to read from the scanner. We've used graphics objects to draw. We've used random number generators. And then we've used arrays, sets, and maps. Lists, sets, and maps toward the end of in the 6th week, we talked about those. That was the subject of the 6th problem set, and you need to be very familiar with that, with those things. What about that last line there, integer, double, character, boolean? They're what?
Primitive wrapper classes.
Yeah, he said they're primitive wrapper classes. And their purpose for every primitive, i.e. int, there's a corresponding wrapper class called an integer. So an integer object is just an object that contains an int. And you can do two things. You can create it, and you can get the int out. So you can put the int in, you can get the int out. And that they exist just because there are some, the list, set, and map classes can only contain objects. They can't contain primitives for whatever reason. And so if you want to store an int in a hash set, you have to wrap the int into an integer object and store the object in the hash set. But fortunately, that boxing and unboxing, as it's called, is done automatically for you in most cases. Yeah.
And as far as using a tree set as opposed to the array list, tree sets don't have duplicates, right?
Okay, so he's asking about tree sets versus array lists. So probably we ought to just say, what's the difference between a list and a set? Because you'll notice there are two kinds of lists There are two kinds of sets, two kinds of maps. The difference between them isn't really important to us here. What's important is that they are list sets or maps. And yeah, a list contains things that appear in a specific order and can be indexed. A set just contains some objects with no duplicates. There's no way to index. You don't go get the sixth element out of a set. You just ask, is this element in the set? Yeah?
So if you use something like int x is equal to 5, x wouldn't be an object. But if you use something like string x equals, say, within quotes ABC, then it would be an object.
Yeah. A string is an object and int is not an object. Everything's an object except for the primitive values. All values are objects except for the primitives. Yeah?
On the exam, do we know how to, need to know how to make like we did with graphics, like the draw graph or with the animations?
Yeah, I'm not going to ask questions about the specific methods in the graphics object.
Okay.
If you've got limited room on your sheet, I would certainly pay attention to the string and scanner methods, as well as list, set, and map methods. Yeah. Okay. Any other questions about this slide here? Yeah.
So when you're comparing the value in a tree map, can you compare it to a primitive integer type? So can you say like a value in a tree map is equal to 2? Will it compare the memory at which that value is stored? Or will it compare, if the two values stored in the same memory location, will it compare them as we think they compare them?
Okay, so I'm going to restate what he said. If you have, let's say, a map, what's the fundamental operation on the map? Or what's a get? So let's say it's a map that maps integers to strings. So to get something out, you would say get to, let's say. And it would find the string that to maps to, if there is one, in return. And he's asking, how does it, so internally it's mapping 2 to a string and you're giving it a 2. How does it decide that they're the same, if the value you're giving is the same as the value it has? And the answer is, it uses you can only store objects inside of a map or a set or a list. It uses the equals method for that class. So in the case of a map that maps integers to strings, it would use the equals method provided by the integer class to decide if two things are the same. And the equals method for the integer class just compares the ints, the contained ints with other equals. So it does what you'd expect. Same int. And that's a fine point. The key thing is to be aware of how to use list sets and maps. Sort of at the level of PS6. Yeah?
So as far as the exam goes with the file objects, there really isn't going to be much implication of it other than...
Yeah, there's not much to know about file objects, except they're useful to pass to scanners so you can read from a file. I don't mean to imply that I'm going to cover everything that's on these slides, or even that I'm going to pick randomly from things on these slides. I'm just trying to give you a comprehensive look at all that we've done. Okay, and there's not much to this slide here. It talks about what an application is. So as far as we're concerned, you have an application, you implement a main method, then your application takes input, either from system.in or from some dialog, and then it produces output, either to system.out or to some dialog. And as you saw in PS5 and PS6, a lot can go wrong when you interact with the user. And typically you find out things have gone wrong because exceptions are thrown. And to make an application that doesn't crash most of the time, you have to catch those exceptions and do something reasonable. We've already talked about test-driven programming, which is basically write the test first. Okay, So we were just now talking about list sets and maps, but they deserve their own slide. So there are two types of each. Lists are like arrays in that they can be, you can look up by index, you can change what's stored at a specific index. They're different from arrays because they can grow and shrink. They're different from each other. They're efficient in different circumstances. So it just comes down to an efficiency question, which you would use. Yeah?
Is the difference between array list and linked list the same kind of difference between like a hash set and a tree set in that they're just the way that they're implemented?
Right. Right. So, yeah. So what she's asking is, there's some difference between array lists and linked lists. And the difference is they're implemented using different technology, different data structure. And, I mean, the bottom line is that array lists are very efficient when you do indexing operations. Linked lists not so good. Linked lists, on the other hand, are very efficient if what you're doing is adding elements to the middle of a list. Array lists not so good. So that's we don't really get into that in 1410, but that's why they're both there, because each is appropriate in different situations. And the differences between hash sets and tree sets there are also differences. It's a different kind of difference, but it's still an efficiency difference. Okay? A set is like a list in that you can add and remove values from a set. The difference is there's no indexing, and the main question you ask about a set is this element in the set? You use the contains. And then maps map keys to values. So think of a phone book or something else, a dictionary. Or physical examples of maps, where there are keys, the things you look up by, and values, the things that are associated with the keys. You saw lots of examples of maps in PS6. Any other questions about this? This is sort of the last thing we did. It's probably the least familiar to you. You certainly had the least practice with it. Yeah?
So hash set is like the dot add, the dot remove, and then the maps or the dot.
Well, sets have an add method. Maps have a put method. Put and get. Yeah?
So in sets, you couldn't call one thing inside of it, you have to call like everything inside of it, since there's no key.
All right, for a set, the main method, the most important method is contains. So you'll say, does this set contain for each? Also, with a for each loop, you can iterate through the elements of a set without having to generate indexes. Yeah?
Say you want to create a map with certain values in it. Mm-hmm. Is there any way you can go about it other than creating an empty one and then putting them one by one?
Okay, so so he's asking, is there a shortcut to creating a map other than creating an empty one and then adding key value, add another key value, add another key value? You can look at the constructors that are provided by list sets and map classes. And for example, you can pass a set to the constructor for a list. And it'll just pull the elements out of the set and make a list from it. For maps, though, I'm not sure, I don't know of any. You can create a map from a different map. You can basically take a map, pass it to a map constructor, and you get a copy of the other map. So there are some shortcuts, but it's just a matter of looking at the constructors for these classes and also look at the class called collections. There's a class called collections that has static methods that may help you out there too. Any other questions about lists, sets, and maps? All right, we did a lot with loops. That's because most programs have loops. And I don't want to dwell in great detail on these slides here because it takes too many clicks. You should know what our enumeration loop is, and you should know what our types of loops are. And what's also on the slide are sort of prototypical examples using of an enumeration loop. This is an enumeration loop that iterates over an integer range from 0 to n. Next is an enumeration loop that consumes a scanner. Here's an enumeration loop that consumes a string. So it's examples of loops. But an enumeration loop is just one that systematically looks at every element in some collection and does something to it. Where I usually just think of it as it's a loop that just prints out everything in the collection. Yeah.
I was just about to say, is it like reads a string, prints out each character individually?
Right. Print out every character in a string, print out every token in a scanner, print out every integer in a range. It's just the most basic kind of loop. It looks at every element and it does something to each element that's independent of anything else, any other element. It's not combining them. It's not looking for the largest. It's just doing something. It's the basis of all the other loops. Well, that's what an enumeration loop is. Now, what's another kind of loop we studied? And first one was accumulation loop. An accumulation loop, you give it some collection of things. A collection of characters, which is a string, a collection of tokens, which is a scanner, a collection of integers, which is some integer range, and it combines them all in some fashion. And here's the thing. If you know you're writing an accumulation loop, and you know what type of collection you're working on, that gives you the starting point. The stuff in yellow is stuff I added that distinguishes it from the enumeration loop. So the white part is the original enumeration loop. The yellow part is what makes it an accumulation loop. And I think, I have a feeling that a lot of you don't believe me when I say that what you need to do is figure out what kind of loop you're writing, take the pattern and fill it out. Because we keep seeing solutions for, say, an accumulation loop that are just sort of off the wall. They're not following the accumulation loop pattern. If you turn every loop you have to write into an invention, you have to invent something special for every loop you write, you're going to spend a long time writing loops. It's when you can recognize the patterns and pull the pattern up and just plug in the important pieces that you can take, that you start to be a more effective programmer. So up here, what are the yellow parts that are common to all accumulation loops? Yeah, what's the first yellow part?
It has a variable to be declared that is going to eventually be declared.
Okay, so before the loop starts, you declare an accumulation variable. That's going to hold, it starts out at some initial value, which is usually some identity value, like 0 or 1. And by the end of the loop, it'll hold the accumulation, and that's what's going to be returned. So that's what the last thing is. You return the value of the accumulation loop, of the accumulation variable. Then what's the yellow part in the middle in every one of these cases? Yeah?
That's the part where the variable you have for that iteration of the loop is combined with the accumulation variable.
Okay, so every time through the loop, you take the next thing, the next integer, the next token, the next character, and combine it with the accumulation variable. Maybe you add it to the total so far, or you multiply it, or whatever, append it. There's some combination going on, so that when you're done, total contains the combination. Right? There's the same thing for strings. So in every case, you've got the base loop, base enumeration loop, which is different depending on what you're accumulating, or what you're enumerating. But then the difference, the yellow parts get added in, are the same in every one of those cases. There is a declaration of accumulation variable, there is a place in the loop where you do the combination, and there's a place at the end where you return the accumulation variable. So you can make writing accumulation loops simple if you know these patterns. Okay? There are searching loops. So in a searching loop, you're just trying to say, you're just trying to find a value in a collection that has some property. Like, find the first vowel in a string, or find a prime number in an interval, or find a token that's longer than 10 characters. And so here is what distinguishes an enumeration loop from a searching loop. So inside, so it's an enumeration loop, but inside you are saying, if the thing we're looking at now is what we're looking for, return it. So you just put an if inside the enumeration loop to see if you found what you're looking for. If the loop ends, that means you didn't find what you're looking for and you have to do something. Either return some value that indicates you didn't find, or you could throw an exception, or whatever you need. That's a searching loop. Okay. Any questions about enumeration, about any of these kinds of loops we've looked at? There's one more to look at. And there's a searching loop on strings. Okay? And then there are optimization loops. And it's sort of like a searching loop, but you consume the entire collection. You're trying to find the best or the worst or the largest, the smallest, the brightest, the dimmest, whatever. There's some superlative involved. And so you turn this just shows you how you turn an enumeration loop into an optimization loop. Like an accumulation loop, you have a variable declared at the top. In this case, it's going to contain the best so far, the best thing you've seen so far. When you're all done, you return it. So it's similar to an accumulation loop that way. But inside the loop, you're just continually asking, is the thing I'm looking for better than the best I've seen so far? If so, I've got a new best so far. So you've got the example here for integer ranges and also for scanners and strings. So you need to be good at this. I might give you a loop and ask you what kind it is, or I might give you a problem and ask you what type of loop would you write for this. Yeah?
In the optimization loop, why is the int I equal 1 while the other is 0 again?
Okay. So, do you want to answer the question?
So because you need something to be the best, just taking the first input and setting it to be equal to the first input of 0 is a good starting point, and then you search for something better than the first input.
Okay. So what he said was, look right here. Best so far has to start somewhere. And so I just took the first character of the string as being the best I've seen so far. Now I could have started my loop at 0, but what the first iteration would be a waste then. Because we know the first element is not going to be better than itself. So I just skipped straight ahead to I equals 1. Notice it did the same thing here. Best so far was s.next. And that removes it from the scanner. So this is going to be a different thing. A slight optimization. It's no big deal. Yes?
So it says string best so far equals s dot next. Shouldn't it be
R dot next? Yeah, it should be R dot next. So you can tell I didn't paste these from Eclipse. I just typed them in. And that's the kind of thing when if we were grading this, someone would say, I would probably just let that go if it were, unless there's a different variable called s in the thing. I try to be forgiving about clerical errors when you're not just writing on paper. Yes?
I just want to point out that on the first loop, that s.next would not work unless you're guaranteed to get something in the scanner.
Right. All of these loops, in fact, are assuming that the collection is non-empty. So a typical specification or optimization loop is going to say, it's either going to say the collection must be non-empty, or it's going to say, if the collection is empty, what to do, throw an exception or something. And so if you've got to deal with the collection being empty, there usually will be an if at the beginning. It says, if the collection is empty, throw the exception or return the special value. Okay, so that brings us to the end of the prepared slides. I had also planned today to advance our discussion of implementing classes a little farther, since that's the next assignment, but I'm not going to start that topic with 5 minutes left. So we'll pick up with that next week. But are there any last questions you want to ask before we end? Yes?
I'm kind of confused about the general idea of like input and output screens.
Okay. Yeah, don't make all this rustling right now. We're still live here. So the input and output streams, So what specifically?
Like, could you just sort of describe them? Because I think kind of, like, I thought it was something a little confused about something.
Okay, so you can create an input stream to read from some source. So the usual thing is you create an input stream to read from a file. Or you could create an input stream to read from the console. You can even create input streams to read from a string, to take its input from a string. So they're just, if you're not using, we tend to use scanners for everything. But there are a lot of programs that don't use scanners. You just use an input stream to read bytes or to read characters, what have you. Output stream goes the same way. It's just not something you can output to a file, output to a string, output to the console. Yep?
I'll follow up on that. Is it function similarity to a scanner then? Like if you use it, it would be similar to how you use scanners?
Okay, so she's asking how similar is the experience of using, let's say, an input stream to using a scanner. Usually with input streams, there are also things called readers. There are streams and there are readers. There are all kinds of these abstractions for reading. And they're not as powerful as a scanner in that they don't break things up into tokens. So typically with a stream, you're either going to be reading individual characters or even individual bytes. Or with a reader, which is cousin to a stream, you may be reading lines, but not tokens. So what the scanner gives you is a way to break up the lines into different kinds of tokens. That's not present in a stream. So you don't use you would not use a scanner if you don't care about that stuff. Any other questions I could answer? Yes?
I just wanted to clarify, last week or when you were here Wednesday, I think you said that you expect us to know and understand what JUnit is, but you won't be asking us to write test cases.
Yeah, you should know about unit testing, and that JUnit is the tool we're using.
But you won't ask us write a test case for this method.
I don't think so. Don't give me any ideas. Yeah. Say again?
The test asks questions about how to use a debugger.
Well, he said, would the test ask questions about how to use a debugger? No, probably not, because I'd have a hard time answering that question. I know how to use a debugger, but if you put a blindfold on me and ask, I probably couldn't remember exactly what button to click on. So. I don't want it to be a memorization test. Okay, I'll see you Wednesday.